Okay, one of the areas that I think is most interesting that's going on in AI at the moment is actually all around physical AI. So while mostly I've tended to talk about language models and stuff like that here, really where I see things actually going a lot now is actually along the path of building world models. And a good example of this is Cosmos 3, which was announced by NVIDIA today at the GTC Taipei conference. And in many ways, Cosmos 3 is a whole step forward in creating a world foundation model. So this is an omnimodal, it's multimodal, it can do 5 different modes. It can do text, images, videos, and actions for things like robotics. And not only can it take those 5 modalities in, but it can actually generate those 5 modalities out. And in the past, to do this, basically people would do something like take multiple models and stitch them together to do this. So you might have a vision language model, you might have some kind of action model, you might have some kind of video diffusion or image generation model in there as well. What Cosmos 3 has done is basically collapse all of these into one model. So it's important to understand that this is both understanding, where it's basically taking those inputs in, and then it's got a generation part where it can actually generate out in those modalities. So if you think about this, to get this model to be able to do end to end of any of those 5 modalities in and any of those 5 modalities out is a very impressive task. So how do they actually do this? Well, if we look at the actual architecture in here, we can see that they're using what they're calling a mixture of transformers. So this is a dual tower. So you can see here they've got an autoregressive side. Now this is what they call the reasoner. And this is for basically taking all the inputs in. And then they've got a second tower, which is the diffusion side, which basically is the generation tower. And that basically allows them to generate the different kinds of outputs needed, whether that's going to be things like generate a whole new video for creating synthetic data, perhaps video plus audio, whether that's going to be generating images, whether that's going to be generating out actions that can be used for robotics, etc. And so Cosmos 3 is a huge step forward in this direction. In the previous versions of Cosmos, they tended to section these off and make different models for doing this. So you had like a predict model, a transfer model that could do certain things. Here, though, they've really focused on 3 main models here. So you've got Cosmos 3 Super, which is a 32B model times 2, because you've got the 2 different towers going on there. You've got Cosmos 3 Nano, which is an 8 billion parameter side per tower. So playing around with it looks like that's about 16 billion parameters in total. And then the one that they haven't actually released yet, but does sound very interesting, is an edge version of this, which you would be able to run on device, real time, local hardware, that kind of thing. Now, I've been playing with the Cosmos 3 Nano, and it's pretty impressive what this thing can actually do. So for a while now, one of the key things of the Cosmos models has been the ability to actually scale up creating synthetic data. And Cosmos 3 really takes this to the next level. So I'll show you a video later on that I made using this model to do inference for creating video data to basically train up a robot arm or robot arms to actually pick things up. Now, the use cases for this are going to be many. You can imagine pretty much every robotics startup is going to be playing with this kind of model to both be able to create synthetic data for them to learn on, but also create data which can then predict out next actions and stuff. Don't forget, this is not just a random video generated. This has been trained to actually be grounded on being able to go from images to actions and videos to actions. Now, along with the open weights that they've actually released here, NVIDIA has also released a very substantial technical report that not only goes through the model architectures, but it also shows where they used other models off the shelf to be able to incorporate in this. So they've made strong use of the Qwen 3 VL models, the 8B for the Cosmos 3 Nano and the 32B for the Super. But they've also been able to reuse the 1, 2.2 VAEs in here, and I think other elements for the audio and image encoders and stuff in here. Now, it is really interesting how they've come up with this 2-tower mixture of transformers architecture, where they've got the autoregressive on one side and they've got a diffusion model on the other side, and how these are able to share multimodal attention across the two. Another thing that I think is really useful about the NVIDIA papers recently has been their whole sort of breakdown of what data they're using for pre-training for this kind of thing, and then also what data they're using for supervised fine tuning. And we can see that in here for the reasoner data, where we can see, okay, what they've actually used for pre-training and then what they've used for SFT. And I think that becomes a really good guide if you want to basically take one of these models and fine tune it to for a very specific use case that you want to do. If you've already built up some real world data for training something with physical AI, this model now allows you to basically expand that massively. And you can see that here in some of the examples where they're basically rendering things out with semantic segmentation, but they're also then able to render out full color videos. All right, so I've been basically testing this out, doing inference with it on a DGX Spark, and you basically pass in a JSON file of what it is that you want to generate. So in this case, you can see I've got the model mode being text to video. And then you can see the prompt here is all about basically a wooden display cabinet with various fruits, including bananas, apples, pears, oranges. And then the robotic arms are basically positioned at the bottom to actually go through and pick these things up. So you can see for basically just text to video here, this is actually a pretty good rendering out. Now, it doesn't seem to be perfect, that occasionally it seems to lose consistency, perhaps when it drops the objects. But we also could have rendered out text to image. We could also render out text to video with audio, image to video, video to video, where we can actually have it change the video as it's going on. And then we can also have it do things like forward dynamics, where it predicts the next state given a particular action. So you could imagine you can feed in something where perhaps you've got some kind of representation along with an action and then have it predict out what would actually happen based on that action. So overall, this is not going to be the most common kind of model that people are going to be using, but certainly you can make the argument that if we're on the path to AGI, these kinds of world models are going to be a huge signal as to how far on that path we are. It really shows how this learns a different kind of intelligence that does relate to the physical world much more than any of the language models alone learn. So I've put the links in the description. You can go and check it out yourself and actually see how these things are actually developing. And if you are interested in doing anything with robotics or physical AI, these models are going to be crucial to what you're actually doing. So let me know in the comments what your thoughts are about this kind of thing. As always, if you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.